All right, welcome back to part 2 of section 1.1. Okay, so we were defining inequality. That's what we were starting to do. So let's say you have two numbers on the number line. Now, what is the number line? It goes from, so the number line, just in general, for those of you that it's been a while since we've talked about a number line. Okay, so it begins like at negative infinity, and usually it has a couple of, increasing from left to right. So sometimes you'll have 0, this will be 1, this will be 2, and so on, to positive infinity theoretically, right? But it's countable, so it's not really like we ever get there. And then this would be, now sometimes there's all different types of number lines, but that's kind of like, when you see a number line, you assume that all this is there. So it's a way to depict numbers, in one dimension. So if you have a number that's less than another, okay, we write it to the left of the number line, okay? And if you have a number that's greater than the other, like let's see here, we have A greater than B, it's to the right. Okay, so let's talk about symbols. We have does not equal. This A does not equal B. So for example, 1 does not equal 2. Okay, A is less than B. So here 1 would be less than 2, and that's correct. A less than or equal to, that's the same as this. This also would be fine. Then you would write, if you have 2 greater than 1, that's where, you would use a greater than sign. And then, of course, 2 greater than or equal to, 1. So let's say here we have translate from algebra to English. So you would have, 17 less than or equal to 26 here. 8 does not equal 17 minus 3. 12 is greater than 27 divided by 3. And then y plus 7 is less than 19. So that's how we would translate those inequalities to English. Let's talk about grouping symbols. So grouping symbols can be parentheses, brackets, braces. And we're going to be adding to the grouping symbols as we go on. But let's go ahead and start with these. So you usually prioritize what's in grouping symbols first. So you solve that first. So here we have 8 times the quantity, 14 minus 8. So 14 minus 8 is 6. So you're basically saying 8 times 6, and your answer would be 48. How about this second example? We would do 9 minus 8 first. Okay, so you have, because that's the innermost grouping symbol. So we have 21 minus 3 times this bracket 2 plus 4 times 1. Okay, so then you would have 21 minus 3 times. What's 2 plus 4? That's 6. So you'd have 21 minus 18. So then your answer would be 3. So here we have 24 divided by, and then in braces, 13 minus 2 times this bracket, 1 times 6 minus 5 plus 4 in bracket. So we would focus on the innermost parenthesis first. So 24 divided by, and then you have 13 minus 2 times, and then what's 6 minus 5? That's just 1. So 1 times 1 plus 4 and braces. So 24 divided by, begin braces. So this is 13 minus 2 times 5. Then you would have 24 divided by 13 minus 10. 24 divided by 3, which is just 8. Okay, what's an expression? An expression here is, it's a number, a variable, or a combination of numbers and variables. So an expression basically does not have an equal sign. No equals. That's expression, right? So, here you have an expression 3 plus 5, n minus 1, 6 times 7, and x divided by y. Those are some examples of expressions. Equation, you would have an equal sign, right? So, so 3 plus 5 is equal to 8. We have here n minus 1 equals 14. 6 times 7 equals, you see what I'm getting at, x equals 53, y plus 9 is equal to 2y minus 3. So here we have determine if each is an expression or equation. Let's not simplify, we'll just say what it is. Okay, so first one, A, it has an equal sign, so this is an equation. Second part, B, for B, there's no equal sign, so expression. C, no equal sign, expression. And then here there's an equal sign, so this would be an equation. Okay, so yeah, so more of the same, right? This is the same thing, but just written in a different way. Okay, so then finally, let's introduce exponential notation. What does it mean to have something raised to an exponent? So a to the n means multiply a by itself n times. So let's say, for example, 3 to the power 2, that's 3 times 3, which is 9. Okay, 9, this is an a. Okay, so we would write this a to the nth, we would say it a to the nth power. So let's say here you have 7 squared. We usually read the little 2 and when there's a little 3 as squared or cubed. You could say this 5 to the 3rd power or 5 cubed, 9 to the 4th power, 12 to the 5th power, and so on. Okay, now that we've talked about all these different things, okay, so we have here, how do we simplify an expression if we have so many different grouping symbols and multiplication and division and addition? How do we know which ones to do first? And, you know, how to solve it properly. So the little mnemonic that everybody knows is PEMDAS, right? So PEMDAS, please excuse my dear Aunt Sally. You have all the so when you see an expression, so let's say you have 3 plus 4 minus 2 minus 7 or something like that, we look for grouping symbols first and we attack that and we simplify that. Then we'll do any exponential terms. You know, the P is for parentheses, but it really does mean grouping symbols. Multiplication and division, it have the same priority. However, we usually read from left to right. And the same goes for addition and subtraction. Okay. So yeah, so quick, fun way to remember it is please excuse my dear Aunt Sally. Okay, so let's say here we have 18 divided by 6 plus 4 times 5 minus 2. So that's the parentheses right here, right? So this is a parentheses. So that would be, I just write everything else down. Plus 4 times, and then 5 minus 2 is 3, okay? Then there's no exponents. So now we're going to multiplication and division, going from left to right, okay? So 18 divided by 6 is 3 plus, and then 4 times 3 is 12. Then finally, we would add, and that's 15, okay? Let's simplify another. For funsies, right? Parentheses, so PEMDAS. Please excuse my dear Aunt Sally. Parentheses first, right? So that would be 5 plus, and then we could do an exponent because it's separated by that. That's fine. 8 plus 3 times, and then what's on the inside is 6 minus 3 times 2. 6 minus 3 times 2, so we would do that next. So 5 plus 8 plus 3 times 6 minus 6. Oh, well, that's nice. That's just a 0 here, right? 5 plus 8 plus 3 times 0. Well, 3 times 0 is just 0. And 5 plus 8 is 13. So your final answer would be 13. Okay. Next thing we're going to talk about is evaluating an expression. So what does it mean to evaluate expression? Okay, well, they give you a variable expression, and then they give you a specific value for that variable. And all you got to do is just plug it in. So let's say here for A, we have x squared. And then what is the value of x? 4. So what they're really asking is 4 squared, which is 16. For B, it's 3 to the power x, but x is 4. So that means it's going to be 3 to the power 4. That's 81. For C, we have 2x squared, so 2 times 4 squared. That's going to be 2 times 16, which is 32. And then for C, we have 2x squared plus 3x plus 8. So everywhere there's an x, I'm just putting in a 4 in parentheses. So you see that? Times 4 plus 8. Okay, so that's going to be 16 times 2, 32, plus 3 times 4 is 12, plus 8. And that's going to equal 44 plus 8. In other words, 52. Okay, so what's a term and what's a coefficient and what are like terms? Okay, fine. So if you have a term, so let's say a term can also be described as a monomial where you just have a constant by itself, or you have a constant and some variables, but they have to be connected to each other. So it's implied that they're being multiplied. Okay, so 5t, that's a term all by itself. Okay, now the coefficient, that's an important word because I'm going to use it a lot. So the coefficient of a term is basically the constant that multiplies in front of the variable, right? That's usually placed in front of the variable. So terms that have they're just either constants by themselves, or terms that have the same variables that are raised to the same powers are considered like terms. And you can only add or subtract like terms. You can't basically subtract. It's like saying, okay, well, I have apples and oranges. I'm going to subtract 2 apples from 3 oranges. That doesn't make sense. Okay, so they have to be the same variable and the same exponent. So see here, we have 3x squared plus 3x plus 7 plus x squared plus 4x plus 5. So the like terms are, you have 2x squared and x squared. That's a like. Then you have 3x. Oopsies. I don't know. 3x and 4x. There you go. And then we have one more. We have 7. That's a constant. And we also have 5. So now we can just combine them or add the same kind. So we have 2x and x squared. So that's 3x squared since they're all positive, plus 3x plus 4x is 7x today. And then finally we have a 7 plus 5, and that's plus 12. So that's it. We simplified this. Cool. Okay, so one thing that you can do too, so I use colors, or you can circle or square, what have you. Some people, you can use commutative property to write them together and then add or subtract the coefficients, and we keep the variables the same. So, that's up to you. Some people move it around and some people, you don't really have to, as long as you keep track of the like terms and not calculate them twice. Okay, so then let's talk a little bit about a word problem. Remember that the sum means addition, difference means subtraction, product is multiplication, and the quotient is division. Okay, if you say the sum of A and B, A comes first and then B, but it doesn't really matter because it's commutative. Subtraction, common phrase, the difference of, that's interesting because you have A and B. So the first number comes first, the B is the second, it comes after the subtraction symbol, the minus sign. A decreased by, or B subtracted from A, or B less than A. Notice that this is where the order is switched. When you say B less than A, that implies A minus B, and B subtracted from A, then that's A minus B also. So the key words here are less than and then subtracted from, okay? Okay, A times B, product, and multiplication twice, 3 times. And then division, we've gone over A divided by B, quotient of A and B, the ratio of A and B divided into A. So let's do a couple here. We have the difference of 14x and 9. So for A, the difference of 14x and 9. That's it. The quotient of 8y squared and 3. So 8y squared and 3. Okay. C, 12 more than y. So y plus 12. Okay, D, 7 less than, so that comes after, 49x squared. 49x squared. This is a 9, people. Okay, let's do another one. Translate this into algebraic numbers. 8 times the sum of x and y. So 8 times the sum of x and y, like that. Okay, because you're multiplying the whole sum by 8. And then you have the sum of 8 times x and y. So and separates 8x and y. Okay, so let's do a few applications. We have the length of the rectangle is 14 less than the width. Write expression for the length of the rectangle. So width is w, right? So we're going to let width be w. And then the length, okay, so the expression for length, it says length of the rectangle, 14 less than the width. So w minus 14. Okay. Okay, so here we have June has dimes and quarters in her purse. The number of dimes is 7 less than 4 times the number of quarters. So Q is quarters. So for quarters, we're going to use Q. And then for dimes, okay, we have the number of dimes is 7 less than 4 times Q. Okay, so that would be the expression for dimes, 4Q minus 7. Okay, so have fun. So your homework is 1 through 53, odd or every other odd. For those of you that are new to every other odd, what does that mean? So here are the odds, 1, 3, 5, 7, 9. Okay, so when I say every other odd, that means you start here, skip this one, go to the other one, skip this one, go to the other one. Okay, so that's every other odd. Now, I'm leaving it up to you to make a choice. Everybody has different schedules. You can balance whatever. So obviously, the more practice you get, the better you're going to be at something. So, you know, shoot for doing the odd problems. But if you're really crunched for time, at least do the every odds. And then, you know, it's the same to me, just for you. Really, this is homework is for your chance to practice. They're all the odd problems, so you can check your answers in the book. Good luck, and I will see you on the next video.